All right, well, welcome everyone to a live demo, everything to do with walls for higher performance. This course is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the places we live. My name is Brett Little, and I am the program manager here, and I will be your moderator for this session today. This course is approved for multiple continuing education units, as well as our certified green home professional in the materials and energy pedal, and AIA health, welfare, and safety, which may make it applicable to your state-based design or contractor license. If you haven't become a member yet, we need your support to keep these sessions going. You get instant access to the sessions, discounts on paid courses, discounts on green building certification, and many other benefits. I think we've got several of these mugs left here. And so we're going to send one to you if you sign up today before they run out. They're made right here in the US, made out of corn. So we'll put your, once you sign up, we'll give that to you. So greenhomeinstitute.org, become a member. And before we get started, I want to thank one of our top tier sponsors, Indo Window. They improve window performance with window inserts. Think of it like a storm window on the inside. You feel warmer in the winter, cooler in the summer, saving up to 20% on your energy bills. And further studies have shown an average of 10% air leakage reduction with these interior windows. The Indo inserts are made of acrylic panel edged with a soft patent silicone compression tube that presses into the interior window frames to seal the drafts. These are very do-it-yourself friendly, measure to order, size and install. And in many cases, these could be more compliant with historic commissions, whereas other window features just aren't. So check them out over at indo.com. And then thanks to our second tier sponsor, Hfo Window, for new construction, great and new windows that you're installing up to R7. And some of them, they have aluminum products, which have recycled content for sustainability. So check out hfowindow.com. Before we get started with this session, I just want to remind everybody, we always like to connect with some of the sustainability programs, the green building programs, LEED certification programs. And so what we're going to talk about today, and you'll see, and we'll bring it up a little bit more, is the materials and resources, material efficient framing credit section. So these are not requirements. These are credits in the LEED program for single family and multifamily. And this is basically ways of doing advanced framing, which is going to make what we're talking about in this session much more effective if you're using these advanced framing strategies that are listed here and that we're going to be talking about throughout the session. There's additional credits, innovation credits there too for doing that. So you can check that out as we're talking about that and bring up your questions on advanced framing and how it might connect with the benefits in the green building programs. And what happens when we reduce the amount of lumber in a project? We reduce the cost and we can get more insulation fitted in, especially with this particular product. It's pre-insulated and these strategies are pre-insulated. So we're going to get into that. And so what that's going to do is drive your energy and atmosphere usage to higher credits through having either a lower HERS index, so that's 0 being net zero, 100 being built to code home, or the LEED energy budget, which is a way to look at a home purely based on energy efficiency. So either one, when we're reducing the framing, when we're insulating the framing, we're getting those lower points and scoring better. So that's kind of the connections to LEED. So enough from me. I am super excited to welcome Brian Iverson back to the show. I think this is Brian's maybe third time, at least on the webinar, and we've had some other opportunities to record him live in person at conferences back in the old days when there were a lot of conferences. And so I'm thrilled to have you, Brian, and please take it away.
Okay, so are you going to switch over? There you go. Okay, I'm good. I had to make sure it was tilted up right. Okay, so I can only say T-stud for 1 minute. Okay, so this is the bare naked version. We're going to go over the insulated versions. We're going to go over a crap load of things. But mostly what I want to tell you is that, okay, so I call myself old because some days I feel old. And so I'm going to be 62. And so I started in 1974 in construction. when my neighbor hanging sheetrock, so 14 years old, 6'1", 135 pounds wet, so a pure string bean, and I'm out there trying to hang sheetrock with this guy. Needless to say, I had back surgery in 1988, and that hanging sheetrock, I've done a lot, 100 sheets a day, crazy amounts, journeyman sheetrock taper, but that was in years past. I'm also a journeyman carpenter. I've designed 750 places that have been built. And so I have a long degree in construction. I'm a certified energy auditor. And so when I went to school to become an architect, because I did sheetrock work, I couldn't sit at that desk any longer. And so I figured I might as well go back out and go frame. And sitting around, I just didn't do very good. But I've learned a lot. I almost went to work for the big outdoors people. So for some of you older folk, that would be Wyoming, Minnesota, the dome home people. What a crazy thing to I don't know how they ever got legs. Anyway, energy efficiency has always been my deal, along with affordable housing, not attainable housing. That word gets thrown back and forth all together all the time. And I want to separate that word, because there is a way for us to be able to make affordable housing, which hopefully we'll get to by the end of this. But Brett gave me I said 2 hours. I said I didn't think I could get through it in 2 hours. He says, well, you got to get through it in an hour and 40 minutes. So I'm going to try to talk all the way through and to get all the way through it. So I'm going to give you a massive history lesson from 1950 going forward. And so some of us are older, over 50 years old. Some of what I'm going to go through today, you're going to go, aha, yeah, I remember that. And if you're the 40 years old and under crowd, you're going to go, oh, that's interesting. So even though I got this in my hand, so I'll turn it this way. This is now the structural insulated framing system. Structural insulated framing system. So that's what I'll call it the rest of the time until the last minute. But okay, so I'm just going to get into this, and if you got any questions, send them to Brett, because we want to answer them as I go. I have everything on the other side of this door, which is my R&D center for this product and all the other products. And nobody's been in there. So you get to be the first ones publicly to go through that door. I had to move a few things outside, but I want to take you through a whole lot of history. And so first off, I'm going to do is I'm going to tell you what the target is at the end of the day. I'm going to tell you what every deliverable that we're all looking to for as humans, what we all want to leave for a legacy on this earth. You see, this is a typical gas pipe, inch in diameter, comes to a house. But we know today that, in the 1800s, early 1900s, right? You had 12 air changes per hour in a house. You didn't have to worry about having a fan in your bathroom, because all you do is open the door and the whole thing vented out throughout the whole entire house 12 times in an hour. That's what ACH of 12 means, right? Okay, we know how to make structures that this is a 3/8 inch in diameter pipe. This is the smallest gas pipe I could find. After this, I don't know what you do. Okay, so we know how to make structures this energy efficient, but along with this comes other, not necessarily challenges, but we seal things off so tightly that other things show up. So every action has a reaction. Sometimes you don't like the reaction. And so we're going to talk about all sorts of those things so that you understand the history on how everything has evolved over time to get to today. So my goal is to do this, but in order to do this, we're going to talk about this Yeti Cooler. So my goal as a person is, if we're actually able to make affordable housing, we need to get rid of the traditional furnace, the traditional air conditioner, and all that metal ductwork that stands behind me. And we do this today as that structural insulated framing system that's used. Every single project that we're involved in the country is performing. Every single one is performing, not non-performing. So if you build to code and you use a traditional 2x6 studs, that is not a performing house. I don't care what you do with it. You're chucking away 34,100 BTUs per square foot right out. You got to figure out how to save them. So I'm going to give you ways to save them today. Okay, so thermally broken, we'll get to this in a bit. So how do we do this? How do we go from this pipe to this pipe? And if I had electrical stuff, I'd show you lots more. I guess we'll cover that. Okay, Yeti Cooler. Right now, if I was to pack this full, and I've done this test, if I pack this thing full of ice, it's close to 50 pounds of ice solid. This little valve that sits down here on the end, that has to be shut. There's a mimicking one on the other end that has to be shut as well. And I can guarantee you this, that this sitting outside at 100 degrees during the day, about 90 at night, it's underneath the overhang of a boat we went on because we went fishing up Canada. Both of these valves are shut at both ends. After 7 days, one of them had never been used. And when we opened up the lid, all of that ice was still inside. There was not one of it had dissipated whatsoever. But I can guarantee you this: if you had just cracked this thing just a little bit, an itty bitty minuscule hole, you've already allowed heat to go in and the cold to escape at the same time through that itty bitty little hole. Heaven forbid that you crack the one at the other end, because if you crack that one at the other end, now you have flow through traffic. It just runs right through. If you took them both off on a 100-degree day, I don't think anything would last more than 2 days. That's how fast that heat, cold, unconditioned air goes through that structure. So when we're trying to build energy efficiently, we need to seal up all those holes, which that's not this company's job. That's not this job, but that's the language we communicate, because you'll see. Okay, so we want to get rid of this. We're going to teach you how to get rid of this. If we do this successfully, we save $5,000. So one of the largest companies in the United States, president told me that what we have now developed is the first ever product and solution as a whole, the whole entire assembly, that has downstream advantages. So in other words, we can cut the cost of every single build. We didn't add to the cost of the build. Potentially in climate zones 1 through 5, we literally saved money, not necessarily in climate zones 6 and 7, because the temperature spread is too great. Climate zone 1, you're trying to keep your house at 70 and it's 110 outside, that's 40 degrees. When you come up here to Minnesota and you're climate zone 6 or 7 or 8, right? Climate zone 8, you live in an igloo. Our temperature disparity might be 80 degrees. It might be more. And so when you're trying to solve for the northern climates, everybody says, well, you're a northern product, a product for the north. Well, that's not true, because if there was a cost to us, our payback in Arizona is half the amount of time, because now you need to calculate in what's the cost of electricity to air condition, which, by the way, Xcel Energy put in for a 21% increase. Okay, so if they have a 21% increase every couple of years, which is what it's slated to do, that electricity usage and cost is going to keep on peaking out and keep on rising up over time, especially when we start to look at structures that last 100 years. So us in the north, I think it's easier for us to solve in the north. I think it's a piece of cake, which means it's a whole lot easier to solve for the south. So, okay, so that's our target. We have builders today that this is their main plenum. This is their plenum in the entire house. You're going to see one house here that Sustainable 9 Builders did in Minnesota, the most energy efficient house in 2020. And they used us for the backbone of that entire structure. This is their plenum. That's it. And going to every single bedroom, 1.5 inch pipe. That's all that they have. They cut. Those people know how to cut costs, and they do it every day. But they're not the only builder in the country who does that and builds to this performance level. But you got to start out with the right tools in the wall, the rim, the floor, the ceiling. You got to start out with that whole entire right structure in order to accomplish that. So hold on. You're now going to get out of my furnace room. I can't believe you're in my furnace room. Okay, let's go. So research and development. Okay, so yeah, that's my space. This is I have a 2-story garage. I'm fortunate. I didn't know I was going to do this product when I first started out. And now that we're here, I am beyond thankful. I'm beyond thankful that I have the 2-story garage, because I made I made this product completely in the basement. So I hope that you can see that now. All right, so here's what we got. This is, you might have to zoom in order to see all this. There's 6 attributes of a wall, or 6 layers in a wall in a wall assembly that you have to meet. An architect, structural engineer, designer, builder, I don't care who you are. You have to meet. You have to have 6. That's what it takes. There are people who write articles out there that say that you only have to have 5, but they blew the top one. The number 1 solution out there, which we're going to talk about here next. The very first one is you have to solve for your 4 different ASTM tests to solve for wind load. And so we'll talk about that in a second. So you have to have, once you figure out your wind load, you can figure out what kind of sheathing that you need to have. And this is 5 stories tall. So the next thing you need to have is you have to have a thermal break. And obviously, you know what I do. I have that structural insulated framing system. We're all about trying to do the highest effective R value, not nominal R value. Effective R value is crazy. And you're going to learn all about effective R value today and how things are generated throughout this talk. So this thermal break through the wall is important. Solving for air changes per hour is a huge number. And so if you were to sit down with somebody who calculates HERS scores ratings, I don't remember how many states, 20 states in the country who do HERS scores. Brett just said that the average house built in America is 100, scores 100 for an average house. That might be true when you throw in Florida climate zones 1 and 2, where they only require an R value of 13 in the wall, which is I don't know how they get by with that. I literally have no clue how they get by with that. So if we have houses that score in the 30s all the time, 30s, 41, 42, probably about the worst case scenario. You can meet the energy code just by using us and cellulose in the entire country. If you have 2000, the energy code is 2012 or under. If you have 2015 or above, cellulose insulation in what we do in the bare naked version is the U value on performance path is 0.048, and you got to be 0.045 in climate zones 6 and 7. So climate zone 6 and 7, if you have the energy code 2015 or above, you got to do blown in fiberglass in the wall in order to make it. Otherwise, you're forced to put that foam on the outside. Okay, so number 4 is vapor. This is typically done with poly. You'd run your poly layer on the inside. ACH, I've been told by many, so I'm not a building science guy. I'm kind of a building science enthusiast. And I tackle and I challenge building science people all the time, just because I have a long history in the construction industry, and I'm known as a fixer. So I've had to fix other people's problems my whole entire career. So vapor, this is done typically with a poly layer, but you can only have 1 vapor barrier, they tell me, in a wall, but you can have as many air barriers as you want to minimize the transfer of full-blown air through that wall. Exterior water. So water management, that's not rainwater on the outside. This is the moisture that builds up on top of your sheathing or on top of your water resistant barrier to make sure that any moisture from the outside doesn't get to your insulation for the most part.
Brian, can you give us the breakdown on ACH just for some of the folks who want to know what that acronym is?
Yep. Air changes per hour. Okay. Can I do that in just a little bit? I'll break away from that. I will come back to ACH because I got lots to say about it up here. I will tell you that we did, David Meter from your state did some calculations for us on a house that we have that's going on right now. And our score is 38 on a HER score rating. And the air changes per hour going through that whole entire wall assembly, and somebody way more professional that can talk about Pasquale's. I think they say Pasquale. I think he was a French fur trader in Quebec or somewhere. That's not true. Sorry, don't believe that. Anyway, we got the air changes per hour below 0.5, but if we were over 1, we had like 3 more HER score points to add in. So if you can keep clicking the air changes per hour, that's back to the Yeti Cooler. If you can minimize, or if you can mechanically control the amount of air that transfers through the house, because any amount that comes in free through the wall assembly, the rim assembly, the roof, I don't care where the air comes in, anything that comes in that's free air is unconditioned. So if you're in a humid area, you're just piling more humidity into the house that now you got to condition. Same going the other way. It's 110 degrees outside, and you're cooling your house to 68 degrees, because that's what I like to keep it at. You're letting all of that cold air, that nice, crisp, cool air, dry air that you have inside, and you're allowing it to transfer right through it's like having a screen on your window. You're just allowing it to go back and forth. Well, if ASHRAE says you have to have 0.32 air changes per hour is what you have to be healthy. I think, don't quote me, but I'm pretty sure that that's what it is. And so if you can maintain that through the whole entire structure itself, then that's when you have the least amount of utility bills to have to manage. So people don't have extra money anymore. Gas prices are through the roof for your car. Natural gas, somewhat stabilized. Electrical rates through the roof, but nobody's got $50 or $75 extra a month. So why don't we build structures that are so energy efficient? Solving for ACH is part of that, because I'm going to talk about that next. Is if you can control that, you can control the amount of heating and cooling bills that somebody has for their structure. And I'm just not talking for a year. I'm talking for 100 years. So, okay, I will get back to that. That's my little water bag theory. Okay, next thing that you have to have, number 6, is you have to have this thermal layer. You have to have an R value through your wall, resistive layer. And the higher that you get that through your wall, the higher you get that through the attic, the ceiling, the rim area, through your wall foundation, underneath the floor. You're literally building a cocoon of insulation around you so that you can heat and cool the structure that you live in, your environment, your living, working environment. You want to have that structure be your own, and you want to control what comes in and what leaves within that space. So what we do, we actually give you number 7, because that thermal break through that wall itself is actually a sound break. So our walls that we provide are 20% quieter than somebody else. So if you have a hotel, motel, commercial building, house, and you're next to the railroad tracks, you got next to a highway, we literally have people who don't hear the kids screaming next door, and they can't hear the people mowing the lawn anymore. That's because we minimize the ability of sound to transfer directly through a full-on 2x6 or 2x4 wall. And we just, by having all the dowels inside of there and having insulation packed around them, we minimize that vibration from one side to the other. That's how we did that. Okay, so that's that. Okay, so I'm now gonna flip over to this one right here, if I can. Okay, I'll go a little
closer. Just back it up a little bit. You're kind of out of the shot even further.
What do? You think you need to see me? I don't think anybody needs to see me. Okay, you're going to definitely have to zoom that in. Okay, I'm going to give you 2 case studies. Okay, so case study number 1. Obviously, this first one is built with our product. This has a 2.5-inch thermal break through the wall. They put 5 inches of closed cell spray foam in the wall. They got an R value of 35 through the wall assembly itself. They controlled their air changes per hour below 0.08, mind you. That's an unheard of number. This is a work in progress to get there, but it's because they put that closed cell spray foam in the wall. They plugged up every single hole that they possibly had throughout the entire wall and rim, and part up to the ceiling level. They did not do this in the ceiling itself. This house here won the #1 most sustainable house in 2020. This is what started an entire case study of trying to track through houses that we are a part of and how we educate builders and people and the public on what they are going to end up with at the end of the day. This is a 3,500 square foot house, $50 a month for gas and electric. Yes, they have a big solar array up on top. Her score rating on this, again, is the same thing, 0.08. So super low her score rating, family of 4, 2 dogs, okay? So let's just say there's a 50% reduction in BTUs. I can guarantee you this, it's way more than 50%, and it's probably over 75. But they save, at 50%, they save 59 million BTUs a year. So the National Home Builders Association, along with energy.gov, somebody, they did this study for a 50-year period of time, took them in 10-year increments. They took this study down, but I actually kept a copy of it. That says that 34,100 BTUs per square foot is what we use to heat and cool a house. Well, let's just say that they're right. Okay, that's not 2021 energy code. This would be like 2012 or 2009 energy code. So if they're correct, they save 59 million. You build this house to last 100 years, which we're going to teach you. That's 59 million. That's 5 billion BTUs, 5 billion. Add 2 more zeros to that. This is the legacy we want to leave behind. This is my legacy. I don't know what you want to do, but that's the one I want to leave. Okay, let's look at the next one. This one is not built with us, but this guy wants the 9 1/4, our stud in 9 1/4. Okay, I love this guy because this guy is a testament for every single one of us. So case study number 4, he does a double wall, 2 walls, right? A 2x4 wall, 2x4 wall with a 3-inch gap in the middle. So he does 3-inch thermal break, 10 inches of dense packed fiberglass in that thing, and he gets his R value to 40 because this guy knows something. And I met him. This guy's fun. ACH under 0.25. He hits it on every single house. He does roughly 26 houses a year. Him and his niece. Beautiful people. This is a 1,900 square foot house. That's what they build. 1,900 square foot house. Utility bills in the $25 a month range, 80% of the time on a solar panel. There's a family of 3 in here, 2 dogs. 80% uses solar. But are you ready for the crazy thing is? That's a 1,900 square foot house, 15,000 BTU mini split, and they're in climate zone 6. This is a ducted mini split. He is able to heat and cool that whole entire house because of 3 factors, just like that one there. So we look at 3 things that have to happen in order to cut the BTUs in half, or 75%. Like the highest, okay, net zero. All right, I'm not going to pick on net zero. Okay, well, how about if we say net 20? Let's cut all the utility bills down for gas and electric to 80%. If we can hit that metric every time, you have hardly anything that you're spending left over, because no matter what, you got to open and close the door, right? You got to send out the geriatric cat to go potty. You got to take the kids to softball, basketball. Do you know if there's 4 seasons to hockey? Okay. Somebody's going in and out the door. So that means you always have to condition the air that just came in, because that's polluted air that came in. It's not conditioned air. So you're always having to recycle and clean up that stale, moist, dirty, polluted air that's just came through that door. Okay, so this person hits this metric every time. This is a 48 million BTU savings annually. Okay, this is 75%. That's 4.8 billion BTUs over 100 years. This guy, he is full intention is to leave a legacy. This guy and his niece, they want to leave a legacy. This is their standard. They do it every time. Let's aim for this. But ultimately, what we're here to teach today is we're pretty certain that we can do this right here and not have it add any more to the cost of a build. We're pretty certain. And it's going to depend on the quality of window, which Brett, I'm going to want to talk to those two window manufacturers that you just have, because we know one metric on the windows. So this is a sidebar. I might have a few sidebars today. We want a window that has a U value of 0.17, because if you build your Yeti Cooler that you have right there, then your weakest link is the window itself. And if you have a cheap, crappy window that the window manufacturer doesn't care what air changes per hour and leaks and they rot out, they're junk, the window is always going to sweat. And we don't create moisture in a house, but you have to dehumidify. So if we can save all this money on the equipment, on the furnace, air conditioner, get rid of the traditional stuff, your air-to-air exchanger, you have to have dehumidification. You have to have. And so you might spend an extra $1,000 on a house in order to make sure that happens. Or maybe somebody has to invent, hint, a little different system, because we're going to race down this path and we're looking for that solution. I don't want to have to invent that. I know of other things that have to get invented. So
what does the for that 1.7 U value, what does that translate for those who like to use R value for their windows? Is it like is that the R10 window that everyone is talking about?
I think that's your 7.
Yeah.
What's 1 divided by 7? Come on, Brett.
I'm cheating right now, but I will have it. It's it's 1.4. So that's 10. So that's like what, a 9.5.
Yeah, actually, if we can do a triple glazed window with a good jam, I'm gonna teach you some things here. Okay. So all right. This is 1950. Okay, I'm now going to take you to 1950 and we're going to solve for attribute number 1. Okay. All right, this is 1950. This is our 2x4 wall. 1950. Now we never had 2x6s. We did everything. Everything in the country was a 2x4 wall. We didn't know structural stuff like we do today. We didn't know any of that. This metal brace wasn't here yet. Okay. And what we had was, this is a 1x12 shiplap. I actually had to make this the other day. So this is shiplap sheathing, right? Goes together. That's your joint. That's your joint right there. If you can see that, pretty good cut, I'd say. And we put this on diagonally to solve for those 4 ASTM tests that you have to solve for. And so every structure that we did with wood on the outside. But in the 50s, this wood became way too expensive. And so what we had to do is we had to then start looking for alternatives. And so our first alternative was called Built Right, Buffalo board, garbage board, an S-word board. It was terrible, but we had no choice but to use it. So this was our product. It's literally, I don't know if you can see this, it's just a fiber board. It's made with junk and glue, and they still produce it today, but not in 3/4 of an inch. There is no structural strength to this board at all. There's zero. This is just a sheathing, quote unquote, a sheathing. And moisture gets into it. All it is sheathing. There's no structural strength. So in order to have structural strength, what we had to do is we had to go to we first went to a wood 1x3, 1x4. They called it a lead end brace. So we had to make a notch, 3.5 inches tall, 4 inches tall, 3/4 of an inch deep, and we cut that slot out right there. And then we nailed in a piece of 1x in there. I never had to nail that in. So when I started framing in the late 70s, we had this metal that embraced by then. And so this, all you needed to do was make a saw curve, a fat one, all the way down. You squared up your wall, and then you put your kerf in for this is a T shape. I actually don't have one handy. This is a T shape. So you cut this in, you nailed it on. Obviously I screwed this on because I like screws. But then this wall doesn't rack. So this is how we first solved for racking strength. All four tests, all 4, 5 stories tall, 6 in Canada, all got solved with this. So you put this in, and then you put your buffalo board over the top of it, and that's your sheathing, and off you go. Then some people started playing with chipboard. Bet you know that's called something else in reality. Okay, so this happens to be chipboard. Kind of looks like OSB, right? But this is the predecessor to OSB. This is before OSB ever showed up. Okay, so this, if I actually had a small enough sample, you can break this with your hands. Again, there's no structural strength to this. So I'm already into the 80s. So from 50s all the way into the 80s, millions and millions of houses done. We're all done with a metal brace or a wood let-in brace, and these products right here, or we had plywood. Okay, so plywood, 1/2 inch, 3/4 inch plywood, we had that, but that was $8, $9, or $10 a sheet, and nobody could afford that in the 70s. Nobody. This stuff is $2 a sheet. Plywood was $8 a sheet. So we might see a sheet of plywood on the end of the structure on the corner, or if you have a shear wall, which we're not going to get into the shear walls. I probably just went over somebody's head right there when I said that. You'd have to have that plywood on. Nobody could afford anything, right? It's 1984. 1984 interest rates are 13% interest. You couldn't afford squat. So we went from built right, we went to chipboard, we went to plywoods, and then don't quote me, I think it's 1984, we went to OSB. So, but the OSB was strong enough in structural strength that they got rid of the metal brace. Okay, but other products have always been around. And in 1984, about is when the northern tier states had to increase their energy code, where we couldn't have a 2x4 wall anymore. It didn't work unless you put your some sort of a chipboard on the outside, and then you physically came on and you nailed on a piece of foam over the top of that, or you were forced to go to a 2x6 wall and then increase the R value of the wall from an R value of 13 to an R value of 19. That was $2,000. That's all that cost, but it was $10 a month, and we couldn't get people to qualify for the $10 a month. So everybody's trying to figure out how to cut $2,000 into $1,000. I know this is math that most of you never even recognize, because who cares if a house costs today $10,000? But if our goal is to get to an affordable house again, you have to go through every single system assembly in the entire structure, and you need to cut 100, 200, 500, and you add them all up. And if you can save $5,000, that's what you have to do to every single assembly that exists in a house, in a building. Okay, and that's what we've done. So this is Neocore Foam. This is a BASF product. This is obviously they have it's a chemical bead, and then they actually make this into a board using steam, using water. This is a kind of a fun product to watch get built. The R value of this, I think, is 5, but it's super lightweight. Anyway, okay, and then the advent of having a WRV already attached to it. So if you do the metal brace, this is still available today. This is a Simpson product, so you can do this. That solves for all your racking, and then put this on the outside, and you have your exterior insulation And that way you get a thermal break on the outside, but it's only an inch thick. So you have to decide, is 1 inch enough? And so our products start at 1.5 inches. We're not making any product that's less than 1.5 inches for a reason. So nothing negative there. Okay. So we have this. We're going to end up talking about this thing over here. Okay. Because are you looking at that, Brett? So this is a wall of the future. I know this is 7 1/4. That's a 5 1/2. But this wall assembly right here has all 7 attributes in it. And this company just ships you the wall with all 7 attached all in one. Not 7 layers, not 7 individual layers, but all 7 attached into one. Okay, over here. How are we doing on time, Brett?
I think we're good.
Like, how many minutes are we in?
Well, it's 12:43, so
okay,
yeah, we're 43 minutes in. Yep.
Okay, all right. You might not think that that's a lot of time, but I just talked 45 minutes. All right, so I'm going to take you through assembly after assembly after assembly. I have 50 items. I'm going to travel right through all the way to the other end here. And I'm gonna continue to educate you on every single part of the wall, the rim. I'm gonna try to touch on everything. But if I miss something, just let me know. Send Brett a message, and because I don't want to miss anything. When you're out there working on structures all the time and designing them, and this is your whole career, you get engaged. You see where things were positive, and you see where things were completely a mistake. So we're going to start out with, we'll start out with today. This is today. This is called a 4-corner pocket. This is how we frame 90% of every single structure that gets built today. This is the corner. Do you see a lot of lumber? Yep. Do you think it might not be energy efficient? Yep. This was terrible. In fact, how we first started framing in the 70s, this pocket, this 2x6 was actually right here, and we had the pocket on the outside. So we had to insulate this bloody thing from the outside. So it's raining out like it is right now today. It's raining out. We're framing. We got to keep going. We stood up the wall. You shoved in the insulation. You nailed your piece of sheathing or whatever you had on the outside over the top. You put your top plate on, and you walked away. You had no idea if that fell to the bottom because it got wet. You had no clue. But I can tell you that I've repaired more damage for insurance companies on the corner than any other place in the entire assembly from mold. And I was probably part of the framing crew that caused probably some of that. Anyway, that's a 4-corner pocket. This was the smarter way to go. So this still makes code. This is a 3-corner pocket, but it's 1/4 less lumber. Okay, so this was a huge improvement. This is known as a 2-corner pocket. Meets code, but you don't need all that lumber. You just need a place to nail your drywall and a place to nail your sheathing if you're using sheathing. That's all you have to have. In California, this nailer for the drywall, a lot of times they do a clip. There's just a simple little clip that they put in to hold the drywall on both sides. I don't necessarily like that because I like things getting nailed into place. But anyway, that's a 2-corner pocket. I'm going to educate you here quick. When they calculate wall assemblies for energy efficiency, I'm going to give you something crazy. Do they take the whole house? Do they take the whole building? Corners, king stud, jack stud, windows, doors. Do they take the assembly? Let's just say right now without the windows and doors in, but they look at the whole thing. The answer is no. They look at a 12-foot chunk by 9 foot tall, because the average house in North America is 9 feet tall. So 12 feet wide, 9 feet tall, studs every 16 inches on center, and they calculate that. Well, that's 40% of an actual wall. 40%, that's it. How do I know it's 40? Is because bat insulation, 40% of the bats in a wall are the entire bat. That's it. They just take the bat out of the roll, they stuff it in the wall, and off they go. The rest of it, something happened to it. They got an extra stud. They got a wall interior wall partition that comes in. something else is going on. They have a corner, outside corner, inside corner. They got a window. There's something going on in 60% of the structure. So if we looked at the entire assembly, I'd like to do a whole study or a whole class one day. This is analytical. When I went to school to become a certified energy auditor for NSP, now Xcel Energy, in 1980, 79, what we had to do was we started out learning what's called Fourier's law calculations. So they're really complex, but when you run the whole math formula out, and I know that I only had a calculator back then that had one memory function. So you always had to write things down and do all your calculations out. But when you do Fourier's law calculations, you know exactly if you increase the R value of the wall by 1, you can see the absolute benefit in the entire assembly, and you can calculate out your BTUs, how many that you end up using. But it's a complex formula that nobody uses, right? So now we have HERS score, we have energy efficiency modeling, but the modeling of those things don't take into account a thermal break through the wall. In fact, when the other day we had I'm not going to say it was an argument, we had a conversation nicely. When you put exterior rigid insulation on, I thought that the HERS score rating difference would have been more, but it didn't show up. And it's because the modeling software doesn't take into account all of the attributes that happen when you minimize the transfer of heat and cold through all of the framing system itself. It's a complex series of things, and they're working on it to get it better, but it's not fixed today. So I kind of like my Fourier's law calculations because I know it's exact every time.
Okay. Right. So you're saying the calculation that it doesn't take in thermal bridging at all, or it's just not as much as it could be thinking through?
What we know by looking at all of our track record, right? Yeah. So there's 1,000 places out there. We know about what people's utility bills are. Uh-huh. And based on that, it's a much significant, it's a bigger metric. Hitting ACH, like hardly any builder in the country hits ACH of 1, let alone 3. They're giving out awards in Canada for builders who hit 3 to 4. And I'm like, we hit below 3 and 4 in Minnesota in the 80s. Right. It's like they're not even trying, so if you hit those 3 metrics, the thermal break through the wall, the ACH, and if you get your R value up there, you can cut those BTUs in half. So that doesn't show up in the software programs today. So somebody else, this is an absolute big window for somebody, is actually to build a little bit more complex of a formula. And I know that when you're some of my friends might think like me. If you had a huge Excel spreadsheet where you plugged in how many kids do you have, how old are they, how often do you leave the open and close the door, do you got dogs, do you got this, do you got that, and then you plug all that in, you're really going to get a good accurate testament to energy efficiency and how they're calculated. And then when you look at all 3 metrics, it's really fun to look at real life, not a computer program that you hope somebody's inputting all the stuff in. I'm not trying to poo-poo on any of them, because today it's a good metric. It's a good number to use. I just think it could be a little bit more accurate. That's all.
Thanks.
Yep. Okay. Here's your stud through the wall. This is 24%. I've seen 30% in a wall, as much as 30% in a wall of lumber. When modular home builders are trying to solve for seismic, or when they deliver their modular units to the job site or wherever they're going with them, and they start shaking like this, they actually use double studs on everything in the wall. You want to talk about a lack of energy efficiency. Energy efficiency isn't even in their vocabulary. Okay, so that's your studs. This is a king stud, jack stud, triple. That's how every window looks. That's how every single one of them looks. No doubt there's 13 on average in every single house that's out there, let alone the buildings. So once you look at this metric and you look at all the corners, like they say that the effective R value through a 2x6 wall with an R19 bat is actually 13. That might be true. I don't care if it's 12 or 14 or 15. I don't care whatever the number is. When you add up all this lumber, the R value through this is 6.8 versus the cavity of 19. This insulation right here, or the lack of insulation, when you have cold and heat that transfer through this somewhat freely, it pollutes that insulation right there. It's not like that insulation isn't working, but this cold and heat polluted into that space. So it made the effectiveness of the insulation less because this polluted that insulation. And that's how you get this huge discounted value over the whole thing. So when we came up with this structural insulated framing system that looks like this, can you see that in there, Brett? Without me going, okay. So we created that thermal break all the way through it, which happened to end up being a sound break. So, and when we did that, you'll see here, we quadrupled the strength of a 2x6 because we turned that board perpendicular. So on the bottom floor of a 5-story building on strength, we're still 24 inches on center and we still hold a snow load. That's how strong we are. There in Minnesota, we're using 2x8s on the bottom floor at 8 to 12 inches on center in order to hold up the whole building plus a snow load. So just if you look at multifamily alone, the bottom floor pays for us for the whole rest of the building. So that's your thermal break through the whole wall. So 30% of your exterior now looks like this, or up to 30%. It's like 17 to 24%, depending upon how you frame, instead of looking like that. This is how you whack your BTU consumption. Like this is the fastest, cheapest solution that you can get to solve for BTU transfer through the wall itself. Okay. So this is a jack stud, king stud, cripple right there. That's what you get. So window manufacturers, your sponsors for the daily show, window manufacturer in Minnesota, not saying their name. He said that president said that just by having this in the wall for the jack stud and the king stud will probably get rid of over 50% of their callbacks on having to do with their extension jam, expanding and contracting and not doing what it's supposed to do. But this R value through the stud, through the jack stud right here, that's 14 to 17, 14 to 19, actually 14 to 19, depending upon how you insulate that wall. So this wall is blown in cellulose, blown in fiberglass, open cell spray foam or closed cell spray foam. That's what you stick in that wall. Oh, and sheep's wool. Okay, we did one house this last year with sheep's wool. Okay, a corner. This corner is 254% more energy efficient than the traditional 4-corner pocket. That's a lot when there's on average 8 of these at a minimum in a wall. In fire codes, this is the top plate. This is the bottom top plate. So how we build wall assemblies, we can either have a 2x6 bottom plate and a 2x6 bottom top plate, or we can, for $1 a square foot more, we can finish that story by putting the structural insulated framing system in for the bottom plate and top plate. But that only made your wall assembly 1% more energy efficient. That's what the math says. So there's no payback to do this. But if you're trying to do net zero or your passive house, or you want to finish the story, that $1 a square foot is pretty small in the scheme of things to have to pay for the whole cost of everything. And it finishes the story. Fire, you just use the 2x6 for the top plate. We used to use metal strapping and metal everywhere, except for metal's so expensive. You can't always get it. You can't always get it right now. And so then we just went back to the traditional 2x6 for the top plate. So time value of money, it's all about speed. But you can do, if you want to, use the structural insulated framing system for the entire top wall, as long as you're putting closed cell spray foam in the wall. Just so you know, this is a 99%, 99.2% complete thermal break. through the wall assembly, but they all make the energy code. So this is a quick little, this is Sentry wall panels, a wall panel system, where this is a 7 1/4. The R value through this wall ends up being 44, but they got the WRB on the outside. They got their stud. This is the thermal break right through. And so this is the highest amount of R value that we're able to get at 44. You just backfill this with 1.5 inches of fiberglass, or you spray in that spider fiberglass. So you don't need the net or cellulose to finish the front off. And then they pre-drill the hole for the electrician right away. So that's all done. Okay, I know that we're over an hour. I'm going to keep working my way down. Now we're going to get into some structural stuff here. Okay, so here we go. A 2x4, traditional 2x4. This holds 900 pounds ish in axial compressive strength. That's it, 900 pounds. That's all. So nobody's building a 4-story or 5-story building using these anymore. This is a 2x6. This, depending upon its grade, stud grade might be 1,600 pounds to 2,000 pounds in strength. A number 2 is traditionally in the 2,200 to 2,400 pounds range to hold in axial compression. Okay, going this way. This is an Lsl stud. Laminated strand board, Lsl. A 2x6 Lsl that I have right here. This holds 3,300 pounds on average. So no manufacturer better get after me, because I tried to look at everybody's. But they just take strands of lumber, like OSB, but big strands of lumber, and then they glue them together. The amount of glue in Lsl is significantly more than in an LVL, laminated veneer lumber. So traditionally, this is the strongest stud that we have to work with. Okay, until I get to the next two. So this on average holds about 4,400 pounds. And but all of these studs all fail in the same mechanical way. So when you get too much of a load coming from the top to the bottom, all of these boards, every single one of them fail in the same mode. This is X, this is Y. So this X dimension, you get too much of a load on it, they bow this way, and then they snap or they deflect out of curve until they can't hold any more load. Obviously, if you get a big enough load on, they're just going to snap completely out. So your sheathing holds them in place for as long as it possibly can, but that's its limiting factor. So when we came up with our system, let's just go to this one. These are our 4 products right here. When we turn that board perpendicular, so hypothetically, this is a 2x6 slit in half to make 2 2x3s. And then we turn this one perpendicular because we stop the ability of the board to deflect in that X axis. So now this is certified to hold, if this is a number 2 plate, that holds 3,600 pounds. Okay, because we crushed the plate at 3,600 pounds. This is actually certified to hold 8,600 pounds, but only if you put it on concrete or steel. If we put this on this LVL plate, if we use this for our plate material, this is what they do hotels and motels with, and they put that on top, we hold 5,600 pounds. Okay, so that's the advantage of this. And then if we were to go, this is the 7 1/4. If we were to put this on, this is 7,400 pounds. So if you're designing and you have a hip set, a big huge hip roof, that hip set, all the weight bears on the very outside corner, and they easily have over 10,000 pounds out there. So traditionally, however you build out your corner, that you would just put us on an LVL if you need to, in order to carry all that load. So this is a strength value proposition all by itself. So we hold 1 to 2 times the strength of an LVL stud. This is perfectly straight. I say that we're almost perfectly straight. Okay, because as you know, the wind travels from east to west. That means the wind as it goes, the wind goes this way, the earth goes this way. That means that almost all lumber is twisted to the right. And if the board's twisted to the left, it was probably on the backside of the mountain.
Hey, Brian, one of the comments that came in from one of our members mentioning that LVL typically isn't used on smaller residential. So are you speaking to more commercial multifamily in this case? Or is this too much for small residential? Is it overkill? Is there wondering? So,
overkill? Actually, a lot of upper bracket houses I don't care where they're at in the country, a lot of them actually, people do spend extra money to get the LSL or LVL studs. And an LSL and LVL stud is just as expensive as what we are, but we're like 90% of the time, 95% of the time, we're used at 24 inches on center. So we end up being a cheaper solution, not to mention we got all 7 attributes through the wall. Okay. So we have the overarching sustainable solution. Lots of LVL and LSL used for kitchen walls, where you want straight, exactly perfect walls to hang your cabinets on. Mm-hmm. They're used a lot. And commercial, industrial, yeah, if they got to hold up a load, yeah, they use these just the same as they use us. And we have some bigger benefits coming. We're on the commercial industrial side. I tried to make this mostly about residential, but on the commercial side, we have a commercial building going up here in Minnesota where we have our wall panel that you'll see in a little bit. And that wall panel is so energy efficient. We got an R value of 44. They only had to have 19. So we're 254% more energy efficient. We got a thermal break through the roof because they used the bare naked T-stud on the bottom cord of the roof truss. So they got a thermal break through the roof. By the way, that math says it's an 11% reduction of BTUs, but I can guarantee you this, it's over 20. And especially if we were down south, that number's for sure over 20% reduction of BTUs by just nailing that onto that bottom cord of that roof truss. Okay, did I answer your question? We kind of just went, it's called tangential.
If not, I'll let them follow up. So,
okay, fire them all off. I got lots of time. Okay, so this product right here, that product right there, 5.5 inches deep. This is 7 1/4. Over 50% of our calls are for the 7 1/4 because this, as you'll see, filled with spray foam. This is a net zero product. This is a SIPS. If somebody's doing a structural insulated panel, SIPS panel, this is directly in line with them. Or if you're doing an ICF house, everybody who calls us today to do an ICF house, we end up with every single one of them because we're $5 less a square foot, some crazy number. Okay, that's it. This is the traditional R19 T-stud. So in the Sentry wall panels, they have this available to them, and the R value through that whole entire stud is R value of 19. And this stud is code certified US and Canada for 16 feet tall and still carry a load. Back to your commercial industrial thing. We will be able to make this 7 1/4 up to 36 feet tall if you nail us at the second floor and the second floor ceiling, and then you get your parapet above it. You're doing a post and beam building, all steel, let's say. You just build your wall, and we'll just stand this whole thing up so that you have the whole entire exterior all done. Pre-drilled holes for the electrician, thermal break, the whole 9 yards. This building right here will qualify for carbon credits, and that is the direction that we're going as a society. Is you make the structure so uber energy efficient, you whack the BTUs down. The benefit is if the government continues down its path. I don't know. This is a long shot. This isn't even a 1% shot. Somebody better start advocating for the person who wants to build this energy efficient. They need to qualify for carbon credits. There's my prayer for the day. Okay. This is what type 1 foam looks like when it burns. It doesn't burn. The Hfo blowing agent in this, the global warming potential of this wall is 3, the same as cellulose and fiberglass. All right. I'm going to pick up the pace a little bit because we got someplace to go. All right.
Brian, as you're transitioning real quick, can you go back to, one of the questions that came in was about certain types of drywalls that require 16-inch on center. Any thoughts on that?
No, yep, no drywall. Let's see, 16 inches on center. They make a 1/2 inch high strength drywall that's able to be used at 24 inches on center. So up until, I'm going to say that became pretty prevalent in about 5 years ago. So before 5 years ago, you were still doing 24 inches on center, 5/8 inch. So you might have to use 5/8 if you have to have a fire code or a rated wall assembly. Sound transmission rates are better with 5/8 than a 1/2. And that's a whole nother subject to get into. But so 1/2 inch high strength drywall, 24 inches on center, no problem. That's what everybody uses. In fact, most of the structures just do all the walls with 1/2 inch high strength because they're pretty rigid and stiff. They make a good wall. So did I answer that, Brett? Okay, good.
Hopefully.
Okay, this is my little bag. I have all sorts of little analogies to show people how energy efficiency works, but this is my simplest one. Air changes per hour. And I'm going to tell you why this is critical. You have to solve for it. I'm from Minnesota. Hold on. Okay, this is a pin. This is a pin. My fingers aren't as nimble as what they used to be. A bag of water. Okay. Poke it right there. Take it out. Can you see that water dribbling? That's what a little pinhole does to your poly. Okay, guess what else? This little pinhole, that might be a pinhole in the window. So if those window manufacturers are online and are online listening, I can tell you that there are window manufacturers out there where 10% of their windows all leak like that. So if you do a reverse blower door test and you go outside with your smoke, you can see the smoke come right through the bloody window. I don't want to tell you who's replacing all the windows in a house right now, but it's not a cheap subject. The window cost was $45,000. They're looking at $250,000 in all total because their seals didn't work on when they manufactured the window. Okay, if you have a hole this big, this is 1/8 of an inch in diameter, right? There's your leak, right? That's all your air leaking out. This is real. This isn't even fake. This is your air coming out. Well, guess what? If that little hole right there, if you sealed off your whole entire window and that hole is right next to the window, where's all the moisture going? Okay, so now I got more stories for you. Okay. So Minnesota, God bless Minnesota. So we created our state, not me. Our state created what's known as Category 1 construction in the 80s. They said, you got to build this energy efficient. You got to do this. You got to do that. You got to put poly. You got to put this. This is green stuff. This is called acoustical caulk. I was this guy. I was this guy that had to go around and put this caulk on everything because you had to. I'm just a kid. I had to go around everywhere and try to caulk up everything because you now had to have like 1 air change per hour inside the entire house. But I'm telling you, if you left a hole this big, all the moisture went out of there. And every stucco manufacturer in the state of Minnesota got chased out because they all got sued in the 80s. Every one of them. And that's because we had no way to tell where that hole was. We didn't have blower door tests then in order to tell. So you hoped and prayed that you found every hole. Well, if you don't catch them all, this is why I advocate for every builder needs to have a blower door test themselves, a tester, a door blaster, duct blaster, blower door. They got to have it for themselves. Because if you check for ACH, air changes per hour, when the structure is under construction, you can reduce that furnace air conditioner ductwork size right away. You know you made the metric. You can't wait for the drywall section when you're done with the drywall, because the drywall might solve for it as well. You can't wait then, because that way all your mechanicals are already on the wall and you already oversized everything. So if you can prove without a shadow of a doubt that you solve for air changes per hour at the construction phase, then you as the builder or the designer or the architect know for a fact that it all got solved. But you can't use bullcrap products when you solve for ACH. Okay, you can't. It's got to last 100 years. If you go from that little pinhole leak, and after 50 years, your product that you used in there, if you didn't use the right stuff to solve for the caulking, or however you're going to solve to plug all those holes, and now that degrades after 50 years, and you end up with that hole, which ends up being that hole, you're going to rot out that window or that door. Wherever that hole is, all the moisture goes out that hole. So I hope you got my point. I've seen windows 1 year. The moisture was so high in the corner of some of these windows. My friends owned a stucco manufacturing company. That's how I know they had to go to Colorado. It wasn't even the stucco manufacturers, their stucco people, it wasn't even their fault. The state of Minnesota should have got sued. Okay, some people hate foam. I'm an advocate for foam because of this, okay? You have to solve, you got to find every single hole. So run around, if you hate foam, run around every window, every door, and as fast as you can possibly go and put just a little bit in, and then come back and chink in those windows and doors with whatever you want to chink them in with. But unless you use unbelievable products to seal them, there's going to be a pinhole leak. And I'm not going to be the guy after this who has to go fix it anymore because I'm too old. Okay, more. We're now going to start getting into Sentry wall panels that use these products all the time. This is a strength value proposition. What we found as a company is that nobody could touch 2.5 inches in the real world. So we decided to create companies on our own and vertically integrate. So you're going to learn about some of them right now. This is a solution for everybody. So we've had to look at every solution. If you use the traditional sill seal around everything, this is so rigid and firm that unless you force it flat, it won't go flat. If you had 5 stories of this, your top floor might not have squished this. The second floor, maybe. The third floor probably did squish it. Otherwise, you have to force it squished. And I have seen this over my day when you try to do a blower door test that you end up with pinhole leaks around it. So this is good and cheap. What we had to do is we had to go to this bad boy. This isn't cheap, $2.50 a foot. This squishes to nothing. So when we do a wall panel, this is what you get. We just ship this out with it. So this is your whole gasketing material. You put this in between the panels, you squish them together. Okay, let's be redneck. They put a ratchet strap around 2 panels, squish them together, and then screw them together with this in between. And if there's any undulation in the wood, it'll solve for that. It'll give you R value, and it'll stop the ability of any air to move whatsoever. And then this is what we put on the bottom in order to, because it squishes down to nothing. So this is Sentry Building Innovations. This is available online. We buy this in the shipping container. I hate shipping containers. You know how much shipping containers are? $12,000 today. The port charge is $3,000, so 15 grand for every single shipping container coming over. Whatever other country it's coming from. The R value through this, I think, is 19. So when you use this product, I think it's called Metza makes it. You have to shove this to the bottom of the top plate, because this side isn't fastened to this side. They didn't, even though it looks really cool, this has a structural challenge, is that if they put this on top the cripples or your jack studs, and there's 2 feet above it, we're going way in the weeds. Here, just nail this to the bottom of the top plate and then do a top sill plate to hold in your window, okay? But the R value is 19, and the LVL. Sentry Wall Panels is actually going to use that product because we know how to work with it. If you ever have to do fire blocking, you start building walls 36 feet tall, we're actually going to be able to do the 7 1/4 clear span 24 feet tall. Clear span 24 feet tall in the 7 1/4, that's coming. And it'll still carry a load. This is fire blocking. So if you got to do fire blocking, you just make a little notch out in order to be able to make that corner in there. And that's how you do that. Commercial buildings. That's pretty typical for a commercial building. The building that we're doing here in Minnesota, the Midwest, as near as I can tell, the Midwest most energy efficient building. This is about what they can get by with. Actually, they're the Midwest's largest solar contractor besides. And so their solar panel system on the roof is like 250 feet long by 24 feet tall on the roof. And they'll feed power back through. So that 12 back into the grid. So that whole entire assembly of that structure, 80% on the solar panel, 20% on the grid or on the grid. And so super energy efficient. And yes, it does qualify for carbon credits. And carbon credits are a complicated thing these days to get calculated out. All right, we're getting down to the nitty gritty here, Brett. Plug you for my cord. Okay, we know what this is. You build structures so energy efficient. You know what this is? This is a waterproof airtight box, $4 a piece at the local store. You start building Sentry wall panels where the whole wall panel is completely sealed. You go back to a $1 outlet box. This is a drain strip. Okay, when you start building super energy efficient structures or any kind of a structure, and you want to try to get venting on the outside, so on top your water resistant barrier and underneath your siding layer itself, you need to lift that siding off of that wall. You need a bulk, they call it a bulk water furring strip. Lots of builders use 1x. But when you do 1x material, you have to leave a 2-inch gap at the bottom. And you know it goes up that little 2-inch by 3/4 inch gap, every bug in the planet into that nice, warm, moist area. So this will actually have a rodent strip on it. So it'll have N316 stainless steel stuck on the end to hopefully make it last 100 years. And it'll have small enough holes to keep them bloody termites out. So this is drain strip. That's coming. We've had to invent all this stuff. We have a couple of other things in the works of stuff that we have to have that we can't wait for other people to go through. Okay, this is the Sentry wall panel. This is the 7 1/4. This is the commercial industrial product. This solves in racking strength. The sheet of OSB holds 500 pounds in racking strength. This particular panel held 746 pounds in racking strength without the OSB. So the cost of the OSB, you don't have to have OSB. You have to solve for ASTM tests. That's what you have to solve. So we were able to figure out a whole entire wall assembly. We took the labor instead of having the OSB, because most of ours, or a lot of us, are old enough to remember that we actually don't have to have it, a sheathing. So we put the labor to install the sheathing into putting in all the closed cell spray foam in the wall. We went to the Hfo blowing agent, not HFC. So hydrofluorocarbon kind of sounds like burnt toast, global warming potential of 1300. This is a global warming potential of 3. So same as cellulose. Same fire retardant in this, same fire retardant in cellulose insulation. It's the same. 8 pounds of liquid in the sheet of OSB. That's what used to be in the sheet of OSB. I don't know what's there anymore, but when they first came out with OSB, there was 8 pounds of liquid chemical. Makes almost 3 inches of pore foam into this wall. So we started building these wall panels, and now we got people's attention that we just reduced the furnace air conditioner sizing and how they did the mechanical systems downstream in order to save the owner, the tenant, the upstream advantages of reduced BTUs. So this wall is certified for 12 feet tall, 5 stories in the air by itself. We'll be able to build these walls up to 36 feet tall and just stand them up on the commercial industrial side. Residential, we just bid out a 76 unit project in Austin, Texas, that I'm pretty sure we're gonna get. We're a little bit higher, but when they start looking at that they can do those small kind of casino type of houses, they're just using a 6,000 BTU ducted mini split on them. All right, fun products before I get into the one behind me. This is cross-laminated timber, mass timber. This is a pretty traditional 3-layer. So, you know, they're starting to do more buildings out of wood. And the reason why they're doing them out of wood is that similar to our wall panel that doesn't burn, this panel doesn't burn, it's all type 1 foam. Wood when it burns, it gets a char layer on the outside and protects it. So unlike steel, when it gets hot, it warps and deflects and you fail your building. They're doing testing now on buildings 20 stories tall, all out of wood, that have a better fire rating to them than actually a steel traditional building. Just interesting technologies coming. So this is known as cross-laminated timber or mass timber. If you're going to try to qualify for carbon credits, we help everybody do it on, it's known as operational carbon reduction. So there's another carbon sequester. And so if you can build buildings, the majority of them, as much of them as you can out of wood, then you're able to check another box. If you can, our box checks everything that you need to have in order to get the carbon credits that some people are looking for. And obviously everybody enjoys the upstream advantage of minimum BTUs and minimum monthly utility bills.
Brian,
but yep.
On that note, are you all submitting for EPDs? Those are the things that validate the carbon reductions.
Okay, that's a ugly, complex subject these days because that subject's changing on a daily basis, Brett. Mm-hmm. They're telling me now that what you used to be able to qualify for carbon credits, and I mean I'm only touching on this subject only for a little bit, just for fun. Mm-hmm. But they're now saying that in order to qualify carbon credits, that you might now have to prove for 2 years or 3 years what it is, and then you can go backwards to qualify for your credits going in reverse. And but the rules are changing on how that happens today. And so if we cannot, I don't know enough to go into that. I just know that we just bid out a 300 unit apartment building in Colorado. And that the whole structure is 154% more energy efficient. We saved like 1 billion BTUs a year. And they saved over $1 million on the HVAC costs alone because we got rid of that magic pack that sits outside. They're like $5,000 a piece installed, and they just went to 6,000 BTU ducted mini splits on the inside. They were, COVID, I guess, thanks for bringing this up. We're probably going to run over 2 hours. COVID changed a lot in the world, especially in the multifamily, hotel, motel, commercial, industrial space, because I don't want to smell your crap. I don't want that mechanical system over there to grab your polluted air and now push it back on me. There are companies out there that have state-of-the-art buildings as of 5 years ago that are now looking at having to go through and redo the whole HVAC system, because if that person sitting over there was hot and they turned the air conditioner on, you 6 feet away, I don't want their cold air, I want to be warm. You have the same air and now you're able to heat yourself. So they have these complex systems, but nobody's taking care of cleaning that air. That needs to get changed in the future as well, especially when it comes to hotel, motel, multifamily, apartment buildings, is that if you live next to somebody else, you don't want their air to pollute the hallway. You want all this conditioned air all over the place. So mechanically, the systems are going to have to become, I'm going to say, simpler. It's because we're able to make the individual units self-contained by themselves easier. And then the individual units have their own air. They have their own little mini air-to-air exchanger, and these things need to be cheap. They can't, $3,200 is insane because they don't need to be. So if you're able to make the individual spaces completely self-contained so that they have their own air, they condition their own air, then all the owner of the building has to do is do the hallways. That's a perfect scenario.
I'm glad you brought up compartmentalization. Where does, what you're talking about here today, is this also an interior wall strategy so we can stop the unit leaking in between? Or is this just something you're recommending for the exteriors?
No, we're an interior wall. We're a party wall. If you do, hotel motels, this 2.5 inch direction, we're equal in strength to a 2x4. Okay, so if you did your party wall, and I got to do the sound transmission rate through them,
Yeah.
Only two times in my life have I ever thought, wow, that's pretty cool what's going on the other side of that wall. Okay. I know everybody's smiling now because you all know it's all happened, right? But we can save an inch. Okay. So if we did all the interior walls in a small unit, just like what we're trying to do, we're not trying, we created another company called Innovated Structures. So we have Sentry Building Innovations, does all of the wall panels, floor panels, roof panels. They do the kit. If you want the whole kit, they'll ship the entire exterior on the same truck because logistics are terrible. When we start doing affordable housing, the Innovated Structures is looking at doing all the interior walls 2.5 inches wide because they still need the structural strength, but they don't need to have 3.5 inches. They only need to have 2.5 in order to make a wall, make a stud stander, slam the door. So yes, we are an interior wall product, but we're not a cheap product compared to a 2x4. So there's not always is that going to work monetarily unless you need to pick up the extra inch. So back to cross-laminated timber. Okay, this is our traditional cross-laminated timber. They're starting to make this. This is a little 3/4 inch cross-laminated timber. They just took 1x material, shaved it down, glued it together, and they shipped this over from Austria. This makes a beautiful paneling, so you can still check the carbon sequester box. The project that we have going on here in Minnesota, this is a 2-inch CLT panel where we're the frame actually. Well, the 7 1/4 panels right here, we actually put this on the outside. And so we have 1/3 of the building done in this wood exterior. We have 1/3 of the building done with metal horizontal steel siding. And we have 1/3 of the building done with that evolved stone. So it is a sexy building, and the front of the building looks like it just came out of the movie Yellowstone. So carbon sequester, this is Vaughan Timbers, and we're going to the AIA convention, and we'll have all the Vaughan Timber stuff in there. We'll have evolved stone in there. We have everybody's wall assemblies in with us because we're the structure, and we go to sleep in the wall. So we might look ugly, but who cares? Because there's no maintenance required for 100 years. Okay, here's a fun product. This actually is glued together by friction. This I don't remember what country these are out of. They actually friction put that together. This little bad boy right here, I'm not going to say who they are. That little thing right there. This is they mechanically messed with the phenyl glue in here. This started as 3/4 inch of material, and they compressed it down to that. And this is Class A fire rated. This will be a siding at some point in the future when they figure out how to mass produce it. But that's pretty fun. Okay, couple things left. This is a mini T-stud. So Sentry Building Innovations runs the residential, hotel, motel, kit house, industrial, everything in traditional construction. But because I'm trying to get all my employees in Newton, Iowa into a house, I don't care if they make $17 an hour. So I had to create another company called Innovated Structures to do the affordable housing solution. And people who live in that size of a house, they don't care how big it is. They just want to get out of mom and dad's basement. And so we're able to pick up some lots from in Newton for about 10 grand, infill lots. These are available all over the country. And so if we can go in and grab those lots for $4,000 to $10,000 and then put a structure on them, that's what we're doing. But we want them all to be net zero. We want them to be super energy efficient, the same thing that we have right here, because I want to leave a legacy that we solve for affordable housing. Throw that word attainable outside, because I don't even care about that word. It's if I make $1 million a year and I can and a $10 million house is attainable to me, that's attainable. Well, no, it's not. It's just that's your house. Just call it your house. But an affordable house to solve for an affordable solution that meets net zero, that takes lots of thinking outside the box. And there is no there's no assembly that's not been looked at in the entire structure, all the way down to the air-to-air exchanger. I don't want to tell you that I can do an air-to-air exchanger for $20. Maybe 15. Okay. So, so I know how to do it, right? So I will tell you that, where's my little product? My little product, I could actually do it for a whole lot less. I could do it for 19 cents. So when you have your, I can't say people's names. I didn't tell them beforehand. If you have your whole entire structure so airtight, okay, I mean airtight, and you go to shut the door, you actually got to put your shoulder into the door to get it to shut, because you're now pressurizing the whole entire part of the house. So then you might have to put on a little vent somewhere, right? It's like a little check valve somewhere in order to be able to get the door shut. Otherwise, a door going out to the garage, it just won't shut unless you physically force it shut. That's how tight you made it. So you have to allow for some air to come in, and that structure has to breathe. I have a accessory dwelling unit next to the house here. Mark Parley, God bless, he's a fixer like me. He said, I'm not even doing a blower door test for you. I'll just give you the report, it's 0. I go like, well, why do you know that? He goes, well, just because your door, you only have a door. I got to do my duct blaster on the door. So I already know the way that you built the whole rest of the structure. It's impossible to have any air leaks in it. And I go like, yeah, I know that, but I want to know. He says, it's 0. Okay, so that's how tight we know how to make them today. It's because we figured out all these assemblies. So this happens to be a floor. This is a floor or a roof. Granted, this thing's not cheap, but we can build these up to 56 feet long. The R value through this is 50. So this is your drywall on the bottom, 5/8 plywood on the top. This could be 3/4 inch plywood on top. This could be 3/4 and 3/4. So it's a floor and a roof. Oh yeah, did you not know that? The 7 1/4, we in this assembly right here, 85 pounds per square foot, we can clear span 14 feet. So not a long ways, but if you're doing hotel motel units where you have to pack in insulation in your floor cavity, because you can't allow air to move horizontally in that cavity of your floor anymore, and they blow in fiberglass insulation there, you can just drop us in as a cassette. And these will be able to be made in the future up to 56 feet long with all finger joint material. I know I'm nearing the end. I put this up there. We do have our first project where actually we have a second one. So we're doing full 9-foot studs on a structure on a house. And then they nailed this to the top plate, the bottom core of the roof truss. So the bottom plane right here is the same plane as the bottom of the bottom top plate. And so we just made the wall height a little 3 inches taller in order to accommodate this gap. So we got an 1.5 inch gap right here for a thermal break through the roof. But literally, for what these are, the payback is super fast. Okay, I covered it all, Brett. I mean, there's probably little things. No big deal. We went through a lot of ground.
Yeah. Yeah, no, there are, and there's some questions that came in, and I had a couple of questions. And so let's, spend some time on that. And then I'll go through a quick outro here. But, Brian, there's one of the clarification on something you had said. And that is, so they said, maybe I missed it, but I just hear correctly that the use of CLT, and I'll let you give us the acronym on that, as an exterior finish with the insulated stud as the structure?
Yep. We can actually, so the
what's a CLT?
Cross-Laminated Timber.
Yeah.
Okay. Cross-Laminated Timber. So traditionally, cross-laminated timber, known as mass timber, is like this. You can, these boards run this way. So traditionally, this would be 2x6, 2x8, 2x10 lumber that runs this way. And then inside the center core runs the other direction. And then the outside runs the other way. So it's always done in 3 odd numbers. It's always done in odd numbers. And so they literally build entire exteriors of buildings out of wood done with cross-laminated timber. So this happens to be a custom-made skin that we can get for less than half the money, because we wanted to check the box in this case for carbon sequester. And so they made a skin for us out of 1x material. Actually, what they did is they took 2x material, they ripped it in half, planed it off, and glued it together. So we're 2 inches thick in total. And then literally we're putting this on panels 4 feet wide, 16 feet tall, all the way around the building to give it some character. So I designed the outside of the building, kind of a fun thing to do. Obviously I don't have time to do those things anymore, but it's a pretty sexy looking building. We'll do a whole show on commercial industrial buildings, stand up, tilt up walls. That's a whole nother hour subject. We can literally finish the entire exterior of a building when we stand up the wall, where all the siding, the stone, the whatever you want to on it, you stand it up, and then where the 2 wall panels come together, you just have a fake board and a batten strip that goes on there to cover up the gap, and you have the outside all done.
One other thing, going back to that question on the 16-inch on center and the types of drywalls, one of our members, she was saying that those types of drywalls typically have to have spray foam. Are there any that can use like a dense packed cellulose or the blown in fiberglass you were mentioning, or is that true?
No, you don't have to do spray foam.
Okay.
But I like spray foam. I had a house burned down once. I became a fan of spray foam after that. The tenants started the fire. I didn't even know there was a fireplace in the house. They tore down the walls because, I don't know, whatever the reason was. They started a fire, they burnt the bloody thing down. And so then I started learning about spray foams, and I've always been a fan of spray foam and energy efficiency and plugging holes and, air changes per hour. That's been my whole career. So I talk this way all the time because this has been in me for 40 years. And but you can use blown in cellulose through us. We have cellulose, we have fiberglass. 50% of the jobs that are out there are done with cellulose and fiberglass today. And they literally 24 inches on center, they all use 1/2 inch high strength drywall, all of them.
So there's a question here, why not just use the, I believe the pre-insulated R19 stud for the top and bottom plates, and the O's so for the top, and the bottom plates for the ones that are uninsulated, that come uninsulated, so you don't have to cut uneven studs to accommodate for the uninsulated plates.
Okay, all right. So obviously some T-stud roadie decided that they were going to throw this tongue twister in there.
Yeah.
Okay. So whoever you are, your name better not be Jim, because I know you're on. And okay, so when we were in Canada, we were a Canadian company when COVID hit. Okay, and when COVID hit, we got chased out of Canada because they wanted me to quarantine over the border. Every time I went over, and I said, I can't do that. The 6 other people that can't do that. And then what happened after that is Austin, Texas froze. So with Austin, Texas freezing, the supply chain was already screwed up. When the country got shut down, it destroyed supply chain all across the entire globe, the whole globe. And so trying to get this is called an auto froth foam. So it's still closed cell spray foam. It's just a different kind of a mixture of it. But when we couldn't get our foam anymore because of supply chains, unless you were already in the supply chain, you couldn't get yourself back into that lane. And now fire retardants are a complete disaster in the world. Hfo blowing agent, for the most part, is mandated in all of North America. Not 100%, but it's getting there. Austin, Texas froze. And so when Austin froze out in 2021, the Honeywell Hfo blowing agent plant, 5 out of their 7 bats froze solid and cracked and broke. And not getting into politics, but it's taken them a year to get back online. And now because of supply chain issues and we can't get other things in, the whole spray foam industry is a bit of a mess right now. We do have access to foam because people understand that we have a large appetite, and because we're willing to work with people on certain things, we're going to get things back. But back to answering the question. So this R19 stud will go into the Sentry wall panels right away because I like that R value of 19. We can get spray foam today, but be darned if I can get an auto froth foam to make this work. Just being able to sell these as they are. So they're not saying that Hfo blowing agent, the whole entire plant won't be back on until 2023, the end of the first quarter. And so we're looking at 2023 and beyond, sometime later in the year to actually be able to make this machine to get this foam to make this. But we can do spray foam in a wall. We're actually working at perfecting a pore foam. So when you do a spray foam, your VOCs, volatile chemicals, are kind of sprayed all over the place. And so we're playing with a pore foam that literally you can just pour out. It automatically rises up to a certain level, then stops. And so you get a really sexy product at the end of the day. But one of the bigger advantages is you get more foam. You get more foam per inch. You get higher lift out of it. And so you get higher capacity out of it. So 3 pounds of foam might make 5 inches of foam, instead of spray foam might only make 4. The other thing with spray foam is when you have to do it in 2 lifts, when the 2 lifts of foam go together, that R value where the 2 foams meet is not 6.7. It might be 6, it might be 5.5 if they don't do it correctly, but it's definitely not 6.7. We have pore foams now today that test out unaged at 7.75 an inch. And so aged, it might be closer to 7.25. But when you can do it in a beautiful lift, one lift of a pore foam, it is sexy as all get out in a wall assembly like what we're looking at doing. So that's the route that we would like to see go in the future.
So for those who, like one of our members here wants to, go away from foam, but they still want to get that nice high performance wall. Their question is, are there any uninsulated studs thicker than 7 inches to allow for that?
Yeah, they're not coming until there's a big enough supply and demand.
Mm-hmm.
So we're looking at actually going into Europe at the end of the year, the first of 2023. And they want their minimum stud that they want is 250 millimeters, so 8 inches. And I was just trying to impress you with my millimeters to inches there. I don't know if that worked. Anyway, maybe you better make that one of your test questions, Brett. Anyway, so the 9 1/4 would come out next. And in order to do the, I kind of like spider blown in fiberglass. Okay. It's because you don't need the net and blow when you do blown in fiberglass, because when you spray it up there, it self sticks. And when you're trying to do a fiberglass or a cellulose product blown in, you always have a chance of settling in the wall assembly itself. So spider is made, it's stickier than heck. It's super sticky. Whatever puffs out over the wall as you blow it in, you just screed it off, and then you're able to pick it up and re-blow it in, hypothetically, into the next panel itself. So there is no waste to it, but it's completely stuck into place, no chance of settling ever. And so I kind of like that product as a whole, especially the modular manufactured when they're trying to ship their units down the road, or clickety clackety, they're banging all over the place going down the road. And so I like that. The R value is 4.1 per inch versus cellulose is 3.7. But there's going to be some other products coming out. If the hemp industry can perfect what they're doing, that sounds like a pretty fun deal. The wood fiber stuff. There's some other stuff coming out I can't tell you about. That's 5 years out. That's in the works. Crazily enough, I talked to a guy the other day, no NDA or anything. They're actually looking at being able to take the phenols out of wood in order to make glass. Go figure. So crazy technology is coming. I'm fortunate enough that a lot of people follow me, and people are trying to invent things all the time, and they ask me for some feedback on what they think and to help them get going. I have 10 patents 11 patents filed today in the US, 5 in Canada, 29 countries. And it takes a lot of effort and a lot of money. But when you file a patent, one of the challenges is you have to be able to defend that patent. And so some products that we have coming up in the future, kind of like the air-to-air exchanger, depending upon which one we go to, Jim, I know you're listening, not yours. But if we do a redneck one, I'd rather just give it away for free and say, here, everybody just do this, because it's a cheap solution. And I don't want to have to police that sucker all over the world. And anyway, my goal in life is to affordable housing and to stop wasting our fossil fuels and electricity, and to cut the BTU consumption down across the board by 75% on everything we build, from apartments to commercial to residential to walk-in coolers to RVs. That's my legacy that I want to leave behind for everybody.
Yeah. Well, Brian, we do still have some time for some more questions, and I want to get to those. Before I do, I know you're all going to ask the question, so I'm just going to answer it before you do. And I think someone just did, but yes, you can rewatch this session. It will be recorded. Subscribe to us on YouTube, click the bell, and it will be sent to you the second we have it up. For those of you who watched this live and didn't attend the whole thing, we'll send you over some information to access the session. For those of you watching this on demand, not right now, but in the future, make sure to take that quiz with an 80% passing rate. You can find that quiz on our Thinkific channel or on our USGBC or whatever channel we might be on in the future. You can take that there. Then those of you watching live, look for certs at gutenbergcerts.com, and you will check that your spam there, mark that as safe, and you'll get your certificate there. And before we get to the rest of those questions, a huge thanks to all of our volunteer speakers this year, our board of directors, our executive director, Jose Reina, and our top tier sponsors, Mitsubishi, April Air, Build Equinox, Aware. They all have products that are going to help you get to net zero, get your platinum ratings, and make your homes and buildings healthier. Those who are people who support us, so we appreciate it very much. So Brian, there was a question about the structural engineering reports and documentation and being available, because yes, we hear it, the pushback just against advanced framing and 24-inch on center. We hear it every day. The answer is always no. I mean, unfortunately. And so even that alone is, as one of our guests was saying, so difficult to get people to buy in. And now you're talking about further reducing, the wood, at least on just somebody who doesn't know anything on their immediate look. You're saying, now I'm doing advanced framing and it looks like this piece of lumber has less in it. I'm afraid. So what is there to comfort these structural engineers?
Okay. So I was with structural engineers last week. And so now you're touting all of your sponsors. Okay. I don't really have sponsors itself. Okay. So I'm just going to give you the web addresses right away. So Here's me. I'm Brian Iverson. tstud.com. This is where all those technical evaluation reports are done. Okay. And then Sentry Building Innovations is the wall panel, floor panel. If you want the whole assembly, I'll tell you, this is really fun. We stuck Sentry home kits in here, and like literally we are pricing out houses where we're the wall, not the floor, but we're the wall and we're the roof, but we ship everything but the window right on the same semi-load directly to the job. So Sentry Building Innovations has become a little bit of a virtual lumberyard of sorts, because we literally ship the whole entire enchilada. Okay. So this is our residential, commercial, industrial section right here. This innovated structures, that's past tense, innovated, because we already designed them. This is the climatized trailer kind of aspect of it. This is our affordable house, where it maybe used to be on the trailer, but now you back it up and it comes off the trailer and anchor it to the ground, and you have your affordable housing solution. This is actively being put together right now today. because this demand is, if you solve for this, this is 10 million houses a year, right? Okay, this is a brutal lane to go down because some people can afford a little bit more than somebody else. Some areas of the country want certain things done because they don't want the ugly structure in the backyard for somebody to live in. So in other words, if you got $1 million house and the house next door is $1 million, you don't want them to be able to put that ugly dome home in the backyard. I'm sorry if anybody owns a dome home, okay? But they want them looking nice and classy and whatnot to have them in the backyard. Rental rates are through the roof, but I can see these structures, 80% of the time off grid. That's how super energy efficient that they are. So, and then drainstrip.com is that bulk furring strip rain screen that goes on the outside. And then if you ever need to get a hold of me, it's really simple. Just do info@tstud.com. And then all of these messages will ever get pushed around. Okay, back to answering your question, tstud.com. I might have ADD, but I almost always circle around to finish the question. You're supposed to smile. Okay, technical evaluation reports. In order to become code compliant, there is a crap load of testing that you have to do as a product. We're nearing on $2 million in testing alone for everything that you see here, 2 million. So we're completely code compliant. We chose DRJ Engineering out of Madison, Wisconsin, because they're uber over the top smart people, and they are in this lane every single day. We could have hired, there's 70 different testing authorities in the United States and Canada. We could have hired the #1 brand, but we hired one brand to do the same testing that what we got done, but they sat on the product for 4 months, and I showed up over there and I said, load me up, I'm taking it to someplace else. So then we went over to NTA, National Testing Agency, beautiful people, and got a lot of our preliminary work done from there. And then I drove all the rest of it over to DRJ, and they finished all the rest of it over a 3-month period of time nonstop in order to become code compliant. And so you have bending tests, you have wind load tests, you got hurricane tests, you got seismic tests, you got all these tests. And so they're all in these reports called technical evaluation reports that all prove that you have met all of the ICC requirements and the commercial code requirements in order to become a product. So we've only had one red tag ever, and that was the very first house. And when that building inspector walked in, he said, WTF, what's that? Red tag, I'm out of here. And it's because the technical evaluation reports weren't turned in at the same time as the building permit. Okay, so we've had some education to do. The more of these that get out there, Brett, and thank you very much for having us. But the more of these that get out there to help people, to help builders, to have this solution, if this is what they want to do, they end up having to go to tstud.com. And then under education or testing, I forget what the tab is called, every single one of them is listed underneath there. And when you open up a technical evaluation report, ICC report, whatever their brand is that they have, they list off every single ASTM test that they had to pass, and then they have to give you your results. So when you're doing wall assemblies, just an FYI, the taller the wall, the more wind that's on the wall. So we have a barn dominium going right now. Our studs were 16 feet tall, but because he had a 2-foot tall, like a brick ledge, a block ledge underneath it, his actual wall height was 18 feet tall. And what we ended up doing is going to a 14-foot tall wall because they needed to carry a lot of load on top of it. Usually the taller the wall, the less load that the wall will hold because you have this exorbitant amount of wind blowing on it. What we ended up doing on this one job anyway is we went to a 14-foot tall wall, but we did a 612 roof pitch on the outside and a 412 roof pitch on the inside to vault the ceiling. And they got everything into that structure that they could have had, and we saved them a crap load of money at the end of the day. So having some creativity in design, you really need to know what the person's end result is that they're looking for. And just like I told everybody here, I'm telling you what the end result is that if I can teach you how to do all of this, and we're only a third of the products. Everybody else has other products, right? So I'm promoting everybody's stuff, and everybody needs to do the same thing. But if our job as people is to reduce the BTU consumption and to minimize our demand on the fossil fuels that, you know, some people don't like to use. I like to use some. I like to use some natural gas, but I want to reduce the size of that pipe. So in order to reduce the size of that pipe, you got to make that wall and that roof and that floor and that rim energy efficient. We came up with a modified balloon framing. And so we can run our wall. If you do like a 2-story house and that floor, you do a top cord bearing floor truss, not a bottom cord bearing, you can run us all the way in front of the entire rim. So you eliminate the rim and do a top cord bearing. That way you get the largest contiguous amount of insulation throughout the whole entire exterior wall assembly. Holy crap, is that energy efficient? And it's fast. So this is all time value money. If you can reduce all of these costs, that's why we ship this wall assembly out with all 7 attributes already attached to it. We just eliminated a whole bunch of other people coming in afterwards to put poly on the wall, let alone caulking. I can't tell you how many pairs of pants I had to throw away from that acoustical caulking crap. Okay, did I answer your question, Brett?
Yeah, I think so. The next question is on renovations. And so just speak to us a little bit about renovation barriers or opportunities. The specific question here is about, you know, replacement of conventional 3.5-inch studs with equivalent integrity and improved R value.
Anything else you'd like me to put into that? 3.5, get rid of the stud. Okay, hold on. All right, I live in a 1989 house. If I could walk around the corner right here and take my camera out to my backyard, I'd show you. But, you know, the land. So I've developed 3,000 lots in my day. I've closed a few thousand real estate transactions, and land values are going up through the roof, especially in the last couple of years, doubled in price. And so I live on 6 acres and I'm in the 7-county metro area of St. Paul, Minneapolis. So I have an extremely unique piece of real estate. So if my land was for sale today, just the lot right here by itself, $500,000, and it would be gone in 2.5 seconds. I probably have 50 offers, but I don't want to leave here. So being my 1989 house, my efficiency of this house is terrible. And so I have looked at 2 solutions. I have looked at being able to go back in, take the sheetrock off the walls, cut out each stud, push a bare naked T-stud in place. Hold on. So push a bare naked T-stud in place. Okay, so there's some challenges with this. So on the top plate and bottom plate, you would have to have a clip, an L bracket clip to screw into here, to screw into the bottom plate. But now you got to attach to your sheathing. So now you'd have to go and get the 2-part adhesive, and you got to make sure that this is acceptable. You can run right down the side of the stud and right down the side of the sheathing to permanently attach the sheathing to the side of the stud, because they do this all the time in the modular industry. I don't think you can use that in California, but I know that almost all modular manufactured housing, they don't use screws on lots of things, but they do this 2-part epoxy that they spray on to affix your sheathing directly to the stud. So you'd have to look to see if that's allowed. But that way, I would get this done from the inside of the structure. So that's a possibility. That's not a cheap solution. We have had people literally take the siding off their house and then nail us on the outside. They fixed the mechanical system from the outside of the house because these are older places and they never wanted to touch the inside. And so they do everything from the outside. They redo the electrical from the outside. They do redo mechanical systems from the outside. They move the window out, and then all they do is they screw us directly to the stud underneath, and then we just hang on the outside, and then you can put whatever you want to back on for your siding. That's been done a lot, more than what I know, I think. The other solution we have coming up is at the end of the year. At the end of the year, we're going to have this mini T-stud, and so this is a mini T-stud. This is 4 inches deep. That the innovated structures right here, even the RVs that we'll make will have a 4-inch exterior wall because I want to get the wall to R26. So the ceiling and the floor of all of these structures will be an R value of 50. That solid pack floor roof assembly you saw over there. But all the exterior walls on every one of these will be a minimum of 4 inches to get to that 26, 28 range or bigger. Walk-in coolers, minimum 6 inches. So these can be made anywhere from 2.5 inches thick to 6 inches thick. And they're made in sheets. They're made 1-inch plywoods, and then the same dowel system, and then a Pore Foam in the middle to fill in the foam, to do your thermal break layer. So on the exterior, I had a piece of rock wool. I'm doing rock wool on the outside. So I'm tearing off the siding on one section of the outside. I'm nailing these to the outside. I have rock wool to go in the middle. And because I already had a sheathing layer that solved for racking strength behind it, I'm just going to do the SIGA water resistant barrier on the outside of it. And I'm doing SIGA in this case because I want that first class over the top WRV, because I have nothing protecting my rock wall. Nothing. It's not like closed cell spray foam where that doesn't absorb moisture at all. I have studs laying outside in the yard here that have been out there for 5 years. There's, other than the fact that it's orange, there's no degradation whatsoever. The foam is completely still attached. It's always going to be attached to the stud because it never comes off. It doesn't come off your glasses. So we have this, and this is the best product that we have for the retrofit market itself, because they're all dead nut straight, and structurally we're almost the same strength of a 2x4, but we have the thermal break. We could actually do one side as treated plywood. So if you're like me, I'm going to finish off my garage, right? I'm starting to plug the holes in all the way around, and then we're going to do one side in treated and one side not. And I'm going to do an R26 inside this basement here one day.
Well, I think you'll have to have us back out when you retrofit your house, maybe, and you can show us what you did, right?
Actually, it'll be pretty fun because I have one wall. I don't have OCD, maybe some ADD, but this one wall I look at from in my dining room, I look out and it's just a standard wall. So I want to make it into a piece of art. And so I got half of it torn apart, took out a door, moved a window. I'm getting ready, but now I'm trying to work with what's my products I want to put on there that are going to have the exact solution that I need to have. But at the end of the day, I want it to look like a piece of art. I want it to look like something that's, late 1800s, early 1900s, because I can.
Yeah.
It's just fun.
Some aesthetic, make it look nice. So
Yep.
Yeah, great. Well, Brian, we are at our time. We've went through a lot, so I really appreciate you coming out and joining us. And just remind everyone again where they can go to contact you or learn more.
Yeah, it's just do the info@tstud.com. That's the fastest way.
Okay.
Find me on LinkedIn. I do almost all of my updates on LinkedIn itself because it's a great professional network for me. I have 14,000 followers. I call them T-Stud Roadies. T-Stud roadies are a good term. You can't, we looked at other acronyms, but drinking the Kool-Aid never seemed to work. So we went with roadies. And but here's the 3 company names. These are there's other company names and other ways to advertise this. We have a insulated panel, Sentry insulated panels that we have coming up, but they're just marketing arms. These are the full-blown companies that have the most amount of info. tstud.com, centurybuildinginnovations.com, and innovatedstructures.com. And then here's that drain strip. And the drain strip is a stinking fun product that had to happen. And I can't stand mice. I can't stand mice, and I can't stand termites in at all. And so I created a way to stop them dang things from getting in.
that I think we can all agree with. So, Brian, well, thank you so much. We're going to get going here, but take care, everyone. We'll see you all in June next week, same time, same place. So be well. Thank you.
Okay, thank you.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.